Okay, so I think I'll start. I'll start the intros here. I think it's this is a was designed to be a media only briefing, and at this point it looks like we only do have media on, which is good. But some people registered who weren't media, and we decided that was okay. It just means it won't go on background or on everything will be on the record. And the issue here, the reason we're holding this particular media briefing is that the issue of carbon, you know, the focus is the role of carbon markets in removing greenhouse gases from the atmosphere. And this is if we were talking 3 years ago, we'd have thought this conversation was going to really kick in about 3 or 4 years from now. But what happened in 2020, we saw an influx of technology companies who had deep pockets and had the ability to finance projects that remove greenhouse gases from the atmosphere. At the time, the idea was that the initial phase in the carbon market process was that we would be focusing or emphasizing projects that reduce emissions. The whole idea is to drive emissions down faster now, because everything that goes up now has to be sucked out later. So that was going to be the current emphasis. With the influx of these technology companies led by Microsoft, there was a surge in demand for projects that removed greenhouse gases from the atmosphere before the markets were ready. So we had kind of an interesting thing where projects that were kind of in a piloting phase, and everyone thought these won't be ready for prime time for a couple more years, were getting a lot of funding, but the methodologies weren't in place to evaluate them and to really say, is this a removal or not? The markets have adapted to that, but the science is tough. So what we're trying to do on this is to give you an overview, not so much just talking about what Vera does, but how this whole thing fits together. And I will let the speakers do their own intros in detail, but the sequence is going to go like this. We're going to have Will Burns of Northwestern University, who is going to give us an overview of how what sorts of technologies exist to remove greenhouse gases from the atmosphere that are on land, either nature-based, such as afforestation, reforestation, or industrial, those big carbon-sucking machines. Then we're going to go to Liz Guinessey from Vera, and she's going to talk about a very specific methodology on biochar, which is one that we've been talking. I wrote about it first over 12 years ago, and it didn't kick in, partly for a lot of reasons, which she'll go into. But it's interesting that one of the reasons it didn't kick in was there was no demand, but there were also a lot of scientific and technological issues that needed to be overcome. So she'll talk about that and how Vera developed its methodology. Then we'll go to Steve Crooks of Sylvestrum, who will look at carbon removals in blue carbon or in the sea. And he'll look at technologies that do exist and also those that are really considered next generation. So and then we'll open it up to questions. Now, Liz does have to leave early, so if you have questions for her, we'll give her a chance to answer the questions first. But the idea here is we'll go along. We want to have about a half. We'll let them go. We're not going to push you guys too much. If reporters out there, if you want to ask questions, you ask it in the chat, and you should see a function that says dial in. That lets you, if you want to ask live, pop up like on a live show. You can do that, or you can just ask your questions in the chat. And some people I know want to remain anonymous when they ask questions, especially if it's a subject they don't know that much about. That's fine. That's one of the advantages of this platform is if you're unsure of yourself and you don't want to ask a stupid question. I mean, I always say the only stupid question is the one not asked, but if that's what you want to do, that's fine as well. So I think what we'll do now is I'll let Will go, and this is my first time using this platform, so I'm going to go ahead and share. Maybe Will, why don't you introduce yourself, and while you're introducing yourself, I'll be digging up your slides and sharing my screen.
All right, that sounds great. Thank you very much, Steve, for inviting me, and thanks to everyone who is on the call. Just very briefly, I'm Will Burns. I am a visiting professor at Northwestern University in Evanston in the Environmental Policy and Culture program there. Formerly, I was founding co-director of the Institute for Carbon Removal Law and Policy at American University, which was, as far as I know, the first academic research center that focused on carbon removal.
Okay, and I'm going to now attempt to share my screen. Let's see. It's taking a little while. Huh.
There you go.
Okay.
And can you put it in slide mode, Steve? Is that possible in this system?
I think so. I need to go up and
I mean, it's slideshow.
yeah. Let's see.
Yeah, you're almost there. It's slideshow. It's like the fifth menu item there. A little higher.
Slideshow. There we go.
Yeah.
Okay. Yeah. All right.
And from beginning.
Okay.
All right, perfect. Okay, so I'm going to try to give you a very quick and dirty overview of some of the land-based carbon removal options. But just to set the table, the reason that we're talking about carbon removal, of course, is that while the Paris Agreement sets targets of holding temperatures to well below 2 degrees Celsius and at least aspirationally to 1.5 degrees Celsius, we all know that we are not on track to meet those goals. Indeed, recent studies project that temperatures by the end of the century may be rise somewhere between 2.8 and 3.4 degrees Celsius above pre-industrial levels. The Intergovernmental Panel on Climate Change's sixth assessment report's central estimate is 3 degrees Celsius, right, with potentially disastrous implications for human institutions and ecosystems. And so there's been increasing recognition that if we're going to meet the goals of the Paris Agreement or even come close to them, we're probably going to need far more aggressive decarbonization of the economy, but also assistance from removing carbon from the atmosphere, or carbon dioxide removal options. And so next slide. I want to start off with a working definition from the sixth assessment report, right? Anthropogenic, so human activities that remove CO2 from the atmosphere, and durably, that's usually defined as 100 years or more, stores this carbon in geological, terrestrial, or ocean reservoirs, or utilizes it in products such as hydrogen production, for example, synthetic fuels, high-strength materials. One of the things I want to emphasize at the outset is that carbon dioxide removal should be contrasted with carbon capture and storage, or CCS, and they're often conflated. CCS, by contrast to carbon removal, does not remove carbon from the atmosphere after it's already been released, but rather captures it at the source of combustion, such as the flue stack in a coal-fired power plant. But what I'm going to focus on is carbon removal, which essentially seeks to suck carbon out of the atmosphere after it's been released through various anthropogenic processes. So recent studies from the Intergovernmental Panel on Climate Change have emphasized how important, for better or worse, carbon removal has now become to the narrative about meeting the Paris Agreement. If you look at the fifth assessment report, of all the integrated assessment models they ran that were able to hold temperatures to below 2 degrees Celsius, and there were about 204 of those out of thousands that they ran, 87% of those assumed large-scale use of carbon removal, starting in 2030 and extending out and expanding throughout the course of the rest of the century. If you look, next slide, if you look at the sixth assessment report, virtually all of the scenarios that are run in that analysis indicate large-scale use of so-called negative emissions technologies or carbon removal. And how large-scale are we talking about? Well, both the fifth assessment report and the sixth assessment report are talking about somewhere between 10 and 20 gigatons or billion tons of carbon dioxide annually, maybe as much as 5 to 10 by 2050, and maybe as much as 20 by the end of the century. And to just give you a sense of perspective of what a gigaton of CO2 is, a gigaton is the same weight as all species on Earth other than humans, right? And we're talking about somewhere between 15 and 20 gigatons per year by the time we get to the end of the century. So what are some of the technologies that we're talking about on land? I'm going to very briefly go through those. Next slide. The one that you've probably heard of a lot in the past, click page down on that to get the arrow to come up. The one that you've heard about the most is probably afforestation and reforestation, or the planting of trees, right? Which take up CO2 through photosynthesis and then store it in the biomass of the trees, in tree litter, in soils, and so forth. Estimates vary widely on how much large-scale tree planting programs could effectuate carbon removal. Some studies see a very modest role in the future, maybe only storing an additional 1 gigaton of CO2 in the future. But other studies assume that we could perhaps meet as third of all of the carbon that we need to remove from the atmosphere to meet the Paris Agreement's objectives through large-scale tree planting. But there's plenty of questions associated with the effectiveness of this approach. One is its durability. Climate change itself is likely to obviate a lot of these benefits, right? We've seen massive forest fires associated with climate change in places like Australia and California, and these are likely to seriously escalate in the future, which could result in massive losses of the carbon that's stored. Bark beetle infestation, again, related to climate change, also is devastating trees and releasing carbon. Also, if you're going to plant trees, you have to take care of those trees in the longer term. If you don't do so, especially in the first 5 years, those trees will die. One recent study said that of the massive tree planting programs that we've seen in a number of countries in recent years, within 2 years, about 75% of those trees were dead. Right? And so we're going to need a lot more money, a lot more personnel if this is really not to be a chimerical sort of approach. There's also social justice concerns, land grabs associated with elites trying to get carbon credits. We're worried about ecological impacts of these approaches. Clearing areas like prairie grasslands and savannas, for example, in southern Africa, could result in massive losses of biodiversity, not to mention livelihoods. The second approach that's often talked about is BECCS, bioenergy with carbon capture and storage. So the idea of BECCS is to use biofeedstocks such as trees or dedicated energy crops such as switchgrass or miscanthus or crop residues or municipal waste to produce energy, right? Whether it's in the form of liquid fuels such as ethanol, or to produce electricity, or to produce heat. When we then combust that bioenergy, we can use a system called carbon capture and sequestration to separate out the carbon dioxide, compress it into a liquid form, and then ship it for storage, right? Such as in abandoned coal mine seams, oil fields, or in the world's oceans, or to utilize them. This technology is deemed to be a negative emissions technology because you capture the CO2 when you combust the biofeedstocks, and you plant more biofeedstocks, such as trees, which takes up more carbon dioxide. And so on balance, if it works, you get a net negative impact in terms of atmospheric levels of carbon dioxide. BEX has been privileged in the fifth assessment report and in the sixth assessment report as one of the most important carbon removal approaches in the long term. And it's been estimated that it could capture anywhere between 3 and 5 gigatons of CO2 annually. But there's challenges with this approach. One is cost. Some estimates are that it still costs somewhere between $130 to $175 per ton of CO2 that's captured. Given the current social cost of carbon in many places, that would not be viable, but it likely will be in the longer term. Another challenge associated with this approach is possible public resistance. Will the public allow billions of tons of CO2 to be shipped through their communities via things such as pipelines and then stored under these communities, right? You all know about NIMBY, not in my backyard. People are now afraid of what we call NUMBY, not under my backyard, right? And this could result in litigation and substantially increase the cost of this approach. There's also potential social and environmental issues associated with BECCS. Large-scale implementation of BECCS might require us to divert as much as a third of all dedicated croplands for food right now to dedicated energy crops. And that could result in massive increases in food prices for the world's most vulnerable, as much as 30 to 40% for the poorest people in the world. It could also require huge amounts of water. One recent study said that large-scale deployment of BECCS could require as much water as all the water that we currently use for irrigation on Earth. Additionally, it could have huge biodiversity impacts if we're diverting areas such as areas with trees to create these kind of feedstocks. And one study said that it could have a biodiversity knockoff equivalent to temperature rises of about 2.8 degrees Celsius, right, which is almost business as usual scenario. And it require huge amounts of fertilizer, maybe about a half of all the nitrogen fertilizer that we use on top of the current load, right, which could have huge, again, environmental implications. Next approach, so next slide, is direct air capture, or DACs. The idea of DACs is to construct so-called artificial trees that kind of look like trees with filters on them, or large-scale filtration systems. And the idea is to force ambient air through filtration systems that can comprised of things such as calcium hydroxide or amines that would, again, separate out the carbon dioxide from the rest of the constituent elements of the ambient air and then compress that carbon dioxide and ultimately ship it for storage or use. Direct air capture, it's been estimated, could potentially, at large scale, capture virtually all of the carbon dioxide that is released through various anthropogenic processes. But there are currently only 19 of these plants, and they're capturing only about 9,000 tons of CO2 at this point. There's lots of challenges with direct air capture. One is cost. American Physical Society years ago estimated that it could cost somewhere between $600 to $1,000 per ton of CO2 captured through this process. There are now pilot plants being built by companies such as Carbon Engineering and Global Thermostat, and these companies have estimated that they may be able to bring costs down to below $100 a ton. But one needs to be skeptical. Anytime your error bars go from $100 a ton to $1,000 a ton, right? One wonders if this will ever happen and how quickly it will happen, right? And if these costs remain really high, this may ultimately only be a niche application, and I think the jury is out. Another challenge is energy requirements, especially for separating out the CO2 from the filtration system, a process called regeneration. It's been estimated that at a very large-scale deployment, direct air capture might require a quarter of all of our energy by the year 2100. Right? Now, obviously, if we're using fossil fuels to do that, it's going to obviate a lot of the benefits of using this process. And if we're going to use renewable energy, it begs the question of whether that's the optimal use of that renewable energy, or if it'd be better to try to decarbonize the economy, right? Proponents, on the other hand, argue that in hard to decarbonize sectors, for example, such as aviation or steel, there will always be a demand for other kinds of systems, right, that can take carbon out of the atmosphere. And so that's one of the arguments in favor of direct air capture. Another challenge, obviously, with direct air capture is you're going to have to capture carbon and then store it or use it, right? So all the challenges I talked about in terms of BECCS, of transporting carbon dioxide, storing carbon dioxide, will also apply in the case of direct air capture, unless other approaches can be effectuated. And then finally, one last one that I'll talk about. So next slide is something called enhanced mineral weathering. So chemical weathering is a natural process, right, that continuously erodes away rocks on our landscape and ultimately sequesters all of the atmospheric carbon dioxide in a cycle that can extend for millions of years. The way this works is when carbon dioxide combines with rain, it forms carbonic acid. That carbonic acid strikes the Earth's surfaces. Among other things, it falls on silicate-rich igneous rocks, such as basalt or olivine. And this carbonic acid then dissolves these minerals, and it's converted into various things, including calcium, magnesium, and bicarbonates. These bicarbonates can ultimately end up in the soils, where they can effectively lock up carbon dioxide for hundreds of years, or some of those bicarbonates will eventually, through conveyances such as rivers and lakes, end up in the world's oceans, where species that utilize bicarbonate to build shells, for example, can take up that bicarbonate, and then when they die, ultimately that can be stored at the bottom of the world's oceans. By removing carbon dioxide in that way, it allows more carbon dioxide to enter from the atmosphere into the world's oceans, which ultimately draws down atmospheric levels of carbon dioxide. Now, as I said, this is a very slow process. Every year, the natural weathering process only takes up about 1/4 of a gigaton of carbon dioxide. The idea behind enhanced mineral weathering is to put that process on steroids. And the idea is to grind up silicate-rich rocks such as olivine, wollastonite, and so forth, spread it on land, including agricultural lands, increasing the so-called weathering surfaces by a lot, right? And by doing so, by exposing more of those surfaces to carbon dioxide, take up more of that CO2. Some recent studies have indicated that this approach could ultimately sequester somewhere between 0.5 and 5 gigatons of carbon dioxide per year, right? So it could have a big impact, but it also has challenges. First of all, the mining process could produce the equivalent of 10 to 30% of the CO2 that would be taken up by this process. Second of all, the mining process is a mining process. It might be as large as all of the hard rock mining processes we currently use. So all of the environmental impacts of mining writ large could happen in terms of this process. It could be very costly. Some estimates indicate $450 per ton, right? And that would really have to be brought down. And it's unpredictable what will happen in the world's oceans when you introduce these minerals. For example, olivine can release things such as nickel and chromium into ocean environments. And if it reached critical thresholds, it could have extreme negative impacts in terms of those systems, right? So given the sensitivity of ocean ecosystems and how little we know about these systems, we'd need a lot more research before we would want to go down this approach. And then finally, the last thing I'd want to emphasize, next slide, is that while we are now looking at CDR on virtually every continent on Earth, whether it be natural processes or natural and industrial processes. We're still at an extremely small scale. Next slide. Right now, as I indicated, we're sequestering about 0.1 gigatons of carbon dioxide annually, right? And if you look here, even by 2030, if we're going to stay on track to be able to sequester massive amounts of CO2, 15, 20 gigatons by the end of the century, it's been estimated we need at least 86.5 megatons by 2030, right? But as you can see in 2025 even, it's projected that we'll be nowhere near that, right? So how we simultaneously characterize these approaches to determine their benefits and potential risks, how we deploy them, how we get a cost of carbon that justifies their adoption in a time period that's relevant, right, for them to make a difference, is a huge challenge, right? And there's a lot of hype, in my opinion, out there about how quickly this can happen. But the reality is that it's likely to unfold, as was the case with solar and wind and other innovative approaches, very slowly. And that, I think, is part of the story. And so with that, I will stop. Thank you very much.
Okay, thank you. Let me see if I'm coming back in here now. And there's okay. That was very interesting. I think one thing I wanted to just point out before handing over to Liz is that what's interesting, too, that you touched on, you talked about the risks. A lot of the risks on the forest side are addressed in the carbon standards, but the risks on the it's not the case. I think my understanding is that that's why we haven't seen advanced weathering. We haven't seen methodologies for that yet because the risks are still in the process of being addressed, and that's kind of what brings me to Liz, which is that she she's going to introduce a methodology that Vera developed for the one that you kindly skipped over so that she can get to it, which is biochar. And what's interesting on biochar from my perspective, I'm fairly new to Vera. I remember writing about biochar in 2010, I think, that Vera, or at the time it was the Verified Carbon Standard, was going to start developing a methodology for biochar, and it was going to be the next big thing. And it's taken us 12 years to get to the point that it's here. Maybe Liz can talk a little bit about why it's taken so long and how it was developed, where we stand, and where we go from here.
Yep, happy to. Thank you for the invitation to be here today, and thanks, Will, for skipping over biochar, as I know it's a bit of a popular topic these days.
And now I've got to find Liz's. Here we are. I've got your chart. Let me do it to slideshow so I don't have to be walked through that again. And, oops, hold on. I have to share the screen first. And I do see comments in the chat. Just for people who are sending in comments in the audience, I can't see while I'm sharing the screen because it takes up both of them. So I will get to your comments after this presentation or after Steve's presentation. So here we go. Can everybody see this? And now I'll do. Okay. Everyone sees it? Okay, great.
Yep. Thank you, Steve, for sharing that.
And introduce yourself briefly. I just said your name. Yep.
Yes. So I am Liz Guinessey. I am the manager of food and blue carbon innovation at Vera. And so I work on our food system work stream and on our blue carbon work stream. But over the last year, I've helped with the development of the VCS biochar methodology that I'll be touching on today. Before getting into the methodology, I just wanted to zoom out a little bit and make sure that everyone's on the same page as to what biochar is and kind of get into why it took so long to get to the point that we're at now with this methodology that should be released next month. And so to start, biochar is a carbon-rich material which is created from subjecting biomass to both a high heat and limited oxygen environment. And after the biochar goes through that process, it's usually about 10 to 100 times more stable than the feedstock from which it came from. And so essentially a substantial amount of that organic carbon will persist in both soil and non-soil applications for the long term. And so part of why you've heard so much about biochar lately is that it offers both a near term, so we can do it now, and a large scale CDR solution. In fact, the IPCC estimates that biochar has a mitigation potential of anywhere from 1.1 to 2.6 gigatons of carbon dioxide per year. I know those numbers don't always mean a lot, and so I'll translate that a little bit for you. The higher end of that range represents about 1/3 of the annual emissions from the United States, so it's pretty substantial. And I do want to mention that beyond its carbon sequestration potential, biochar also offers a lot of co-benefits, especially in agricultural applications. So biochar, when you apply it into soil, it tends to increase the nutrient retention of that soil. It improves the water holding capacity, and it can also aerate soil. And so these co-benefits are really important on their own, but generally the process of going through and producing biochar doesn't really provide enough incentive. However, the carbon sequestration potential certainly does incentivize that. And so as Steve alluded to, he was reporting on biochar back in 2010. At that time, we weren't really sure about the science around biochar longevity in soil and its stability as well. However, the science over the last decade has really coalesced, and there's really no doubt remaining as to the longevity of biochar in the soil. And in fact, in the months prior to actually making the decision to move forward with the biochar methodology, we were receiving constant emails from project developers who wanted to develop biochar projects. And another thing to note is that the biochar industry is definitely still in its infancy, so to speak. There are advancements in production technology, but they're not really operating at scale. However, we think that the industry is poised to scale rapidly, and our hope is that the added benefit of carbon revenue can really help for that scaling to take place even more quickly. Next slide, please, Steve. I want to give a little bit of background on where this VERA methodology will live. So we operate the Verified Carbon Standard Program, or the VCS. The VCS is the world's leading voluntary greenhouse gas crediting program, and it represents about 80% of the voluntary carbon market. The VCS is a very rigorous set of rules and requirements. It includes the VCS standard, which is kind of like our Bible. It lays out all of the rules for projects and for methodologies. The standard also includes a process of independent auditing. So an external third party known as a validation or verification body, we call them VVBs, they will do an audit of any methodology or project before it's able to generate credits. The VCS standard also has part of the VCS is a registry system, which is an in-house system that tracks any project and also the generation of any verified carbon unit, or VCU. A VCU is basically just Vera's terminology for a carbon credit that gets produced using one of our methodologies. And then we also house a series of accounting methodologies, and soon we will include biochar as one of those accounting methodologies. Next slide, please, Steve. Thank you. And so the VCS includes a very rigorous methodology approval process in order to actually generate and put out a methodology for use. Basically, we put a methodology through a process of both expert review and then public consultation, the idea of which is that any methodology that gets put out there has as much expert eyes on it as possible, and it makes sure that we're using the best possible science as well. And so the process that the biochar methodology went through was, first there was a pre-consultation phase, and for that phase we actually put together a biochar working group with stakeholders from academia. Some were biochar producers. There were also some project developers in there as well. And we did a lot of surveys and worked with these stakeholders to answer questions on the types of feedstock to include in a methodology, what the baseline setting should look like, different features like that. Once we had all of that pre-consultation data, we actually put out an RFP to put together a consortium of methodology developers. The consortium includes South Pole, For Alliance, and Biochar Works. Those methodology developers then actually took on the task of writing the methodology. Once they had a fully first version draft of the methodology, that went out to public stakeholder consultation. Public consultation entails a methodology being posted publicly on our website, and we then invited stakeholders to submit comments on the methodology. I think that the biochar public consultation broke a Vera record for the most comments received. We received about 250 comments, and they came from 45 different stakeholders, and they represented all kinds of backgrounds. So academics, project developers, people who are out there just thinking about biochar on a daily basis because it's such a hot topic. And so the consortium of developers then took all of those comments and revised the methodology. Then the methodology went on to this external audit process. So a VVB assessed the methodology, and that process basically entails the VVB looking at the methodology and making sure that it follows all of the rules and requirements of the VCS standard. And now we're in the last stage of this methodology development process where we at Vera are doing a final review, and we hope to have the methodology out for use by July of this year, so very soon. Next slide, please, Steve. And so as I said, we expect to release the methodology in July. It will be able to be used in both soil and non-soil applications. And I do just want to point out a couple of innovations of the methodology. Can we do the next slide, please, Steve? All right, so I think first and foremost, and probably of key relevance for this group, is the biochar methodology will generate a nature-based removal credit. The biochar methodology also employs a comprehensive accounting framework that captures greenhouse gas impacts in 3 stages of the biochar value chain. It covers sourcing, so sourcing of the feedstock that was used to produce the biochar. It covers the production stage, so the actual production of the biochar itself, and then it also covers the application stage, and that could, as I said, be in either a soil or a non-soil end use. The methodology allows for a diverse range of feedstocks to be used to produce the biochar, and basically as long as a project proponent can demonstrate that the biomass utilized would otherwise be wasted, and there's also some sustainability criteria as well that needs to be checked off, but there's a pretty wide range of feedstocks that can be used. The methodology is technology agnostic, which means that any type of technology can be used. However, the methodology breaks down technologies by being either high-tech or low-tech, and there's a bit of a discount factor that's included for using any sort of low-tech production. The methodology allows for end use in both soil and non-soil applications, which is a bit unique compared to some other approaches out there. And the methodology also includes the risk of reversal. In fact, there's a need for regular monitoring of any sort of natural or non-natural risk with any of the verification stages of a biochar project. And then lastly, the biochar methodology requires the monitoring of the end use application. And this is actually done through a full chain of custody approach that follows each piece of biochar all the way through to wherever it ends up. And then there's an actual requirement for a geodetic coordinate of each of those end uses. And this is done just to really ensure that there is no reversal of the biochar being placed in wherever it ends up. And that's about all I wanted to cover today. We're very excited about this methodology just because of this huge potential that we recognize for biochar and its ability to be a very tangible removal. And be on the lookout for this methodology. It should be posted in July, as I mentioned.
Okay, sounds great. And I'm going to see, since Liz has to leave, I'm going to see if, let's see, okay, so I'm going to see if there's any questions. Does anybody have questions for Liz? Because she is going to be the one who leaves first. If anybody out there has a question for her, I figure we kind of throw it her way now. Otherwise, we will have Steve and Will through to. Okay, here we go. Here's one. How many projects? hold on, I gotta scroll down. How many project developers are lined up to, is that end there or is there something below it?
I can see it. Yeah, it says how many project developers are lined up to
There it
utilize
goes.
the new Vera biochar methodology. Pretty significant amount. My name is associated with the biochar methodology on the Vera website, and I get about 2 to 3 emails a day from potential project developers asking when the methodology will be prepared for use. I would say that those developers represent a range of preparedness to actually implement on the ground, but we do expect to have a pretty robust pipeline of projects as soon as the methodology is approved.
Okay. We've got another one here from Oliver Lejeune. Hi, Liz. Thanks for this. Just curious how the methodology differs from Puro Earth.
Yeah, it differs in a couple of ways from Puro. So I think one of the key differences is that monitoring of the end use of the biochar through this chain of custody approach. That's something that Puro doesn't cover. The division in the types of technologies that are used and the discount factor for the low tech is also a key difference between our methodology and Puro Earth's methodology. The inclusion of the risk of reversal and the repeated monitoring of that reversal risk is something that's also not found in Puro's methodology as well. And I haven't read the Puro in a couple of months, but those are some of the key differences that I would note between ours and their approach.
Okay. Anything else? And if anybody wants to ask a question verbally, you should be able to click where it says live call in. If you don't see that, you can just put a chat in. But okay, so I don't see anything. Let's go on to Steve now, and Steve will take us into the weeds or into the mangroves. And we might I don't know how long, depending on how long Steve goes, this might be your last chance to ask Liz a question. So if anybody does have a question for her, you can ask it now. Otherwise, we'll go on to Steve, and take it from there. So Steve.
Okay, great.
Okay, and again, once I start sharing my screen, I can't see the chat. So if anybody does have a question or something and I don't answer it right away, I'm not ignoring you. I just don't see you. So let me get to Steve's PowerPoint here, Seascapes, and there we go. And where are we at?
Okay, while you're doing that, Steve, can you hear me okay?
I hear you fine, and maybe you can introduce yourself while I'm doing this.
Yeah, great. So my name's Steve Crooks. I'm with a small company called Sylvestrum, and I've got a background. I've worked for 30 years in coastal wetlands restoration, the science of it, the practice of it. I was involved, one of the co-founders, setting up the International Blue Carbon Initiative to help raise awareness of the role of coastal ecosystems within climate mitigation, as well as other climate resilience benefits, and connecting science and policy around the world. I was a member of the IPCC working group that worked on the wetland supplement so that countries could include coastal wetlands within their greenhouse gas inventories. And I was a member of the team, it was the Sylvestrum team that led the development of the methodologies under Vera for restoring tidal wetlands, so mangroves, salt marshes and seagrasses, and later the expansion of VM7, which is the red methodology. So now there are modules there for including the conservation of the very same ecosystems. And we are now working with Vera to expand that to include seascapes, so other types of marine ecosystems. So as you can imagine, Sylvestrum works on helping countries with science programs, including coastal wetlands within greenhouse gas inventories, helping to include coastal wetlands within NDCs, and then developing finance mechanisms, which includes developing carbon projects so that countries can actually enact the targets that they put within their NDCs. Next slide, please, Steve. So I'm just going to take you down to the shore and get your feet wet a little bit, maybe go for a swim, and just introduce you to some blue carbon ecosystems and where we are in terms of the understanding of emissions reductions and the development of carbon projects around them. This is what they look like. The salt marsh on the right hand side, that happens to be just around the corner from my house, and that represents within those muddy sediments the accumulation of organics which are stored because they're wet and anoxic, and that represents around about 500 to 1,000 years worth of soil accumulation right there. Even for mangroves, the system looks very similar. You can actually in all these systems get very peaty soils, but when you get muds present, they tend to look like this. And but even for mangroves, where the trees can be 100 foot tall, 80% or more of the carbon is actually in the soil, and so it's very important that we manage the soils. And next slide, please, Steve. So around about 2009, the UN came out with a report where they coined the phrase blue carbon, and that was really recognizing the role of these coastal ecosystems and marine ecosystems within the global carbon cycle. Where we came into this was with the, hopefully you can see, my screen's all frozen, but hopefully you can see a table. And we kind of highlighted the importance of recognizing the emissions that were taking place, because there was a lot of deforestation taking place around the world, particularly related to mangroves. And a number of us got together to estimate at the time the emissions that were taking place over the prior 20 years. And it worked out, when you looked at all these ecosystems, it actually took pretty conservative assumptions that there was something of the order of 450 million tons of CO2 being released each year from the soils of these ecosystems. And most of that was conversion of mangroves to shrimp ponds in Southeast Asia, but other causes of loss too. What has been interesting is that since we've started all of these activities, we brought this awareness, we started engaging with the UNFCCC, there has been a strong decline in the rate of deforestation of mangroves, particularly within Southeast Asia. And so that is a good news. So the emissions have been going down on these ecosystems. However, we are seeing it tick up in other places. We're working in West Africa right now. And if you go anywhere along the West African coastline, you'll see conversion of mangroves to rice fields dominantly. And so as food pressures are picking up, we're seeing impacts in other locations. So it's almost like squeezing the bubble or squeezing the balloon a little bit. And so we need to work in a lot of countries. When we turn to the projects, this is an example of a project that is now under Vera, and they're just about to...
Steve, should I be on the mangrove action, or should I be on estimating global...
You can see on this one, Steve,
okay.
if you can see the Indus Delta right now, this is good.
Okay, let me go to the... So the one that says mangrove action.
Mangrove action, right there, Pakistan. Right. And so this is an example of one of the first really large mangrove reforestation projects. Reforestation projects are easier to do from a carbon project development because the baseline is very clear. You don't have mangroves there, you're putting mangroves back into the landscape, you're restarting carbon sequestration again. And so this is the case where it's a 220,000 hectare project. The little corner at the top, the brown just above the Indus Delta, I can't point on my screen, that's that's Karachi, 15 million people. So to give you a sense of the scale, that is an enormous delta. And there will be 1 billion mangrove trees planted as part of this process. And they've already done, close to 80 million now. And as part of this, the delta is being impacted by loss of water because of agriculture upstream. There's been displacement of mangroves directly. The dams are stopping the water and the sediment. And so the whole delta is going through an adjustment, and it's been a very negative adjustment. And so as part of this project, we have to think about sea level rise, we have to think about diminishing water supplies, we have to think about where the mangroves are going to be in the future, and planting them in a way that's going to be most resilient. And so things can gradually evolve in a more robust trajectory rather than a very negative trajectory that was happening previously. Next slide, Steve. And so the last slide, so, we're starting to see these carbon projects developing. There's a lot of finance out there, or there has been until, we started talking about recessions, so we'll see how that all affects everything. But there's been so much financing floating around and there have been very few projects. And so groups like ours are out there trying to find projects. And what we will see, I think, fairly soon is that the easier projects will get taken up, and the cost of these projects will increase because within coastal ecosystems there's a lot of infrastructure. And so what we will have to do, although we are seeing the price of carbon tick up for blue carbon, they're trading, we were lucky to get say $15 a ton a year, 2 years ago. Now we're seeing trades of around about $20 a ton, even up to $30, $40 a ton, which has been very promising. But like I say, we'll see how the recession impacts that. There is a need to develop projects that will get more complicated. Infrastructure is in the way, roads are in the way, we're going to need to build bridges. This is, if the price of carbon is not sufficient, which it most likely won't be, means that we're going to have to bring in other types of financing, climate resilience bonds, etc., so that we can improve the infrastructure to allow tidal reconnection, so we can restore larger areas of these ecosystems. Now, where we are right now, so in this is a graphic that there's been a whole number of reports that you can search out that have come out on the potential of blue carbon related to the oceans in the last month or two. This happens to be a McKinsey report, and looking at the emissions and removals, the top part of this are the established type of ecosystems which are already under the Vera methodology. So we see restoration, protection of mangrove, seagrasses and salt marshes, and the scale of the emissions reductions. I actually think the protection has a larger bar than what they've put in this one. But towards the bottom of this graph, we're now moving into the seascape, and it's going to get more complicated. But also the potential emissions removals are more significant. And so we've already started working on methodologies related to seaweed farming. We're interested in kelp conservation and restoration. And we're also working on a methodology with Pristine Seas and National Geographic related to better seabed management. Because when trawlers go across the seabed, the reef suspends sediment, carbon gets released, it goes into the water column, it goes into the atmosphere. And so we're trying to work on some of these marine aspects. The quantification is going to take a lot of work to be done. There are a lot of questions about regulation, there are questions about safeguards, and there are questions about non-native ecosystems. And so, for instance, if you start, dropping a lot of carbon within the deep ocean, at what point does that have a negative impact on ecosystems, on the environment? When does it become too much? And so this is kind of where we are. Under Vera, we have a working group which are looking at this. We're trying to advance the methodologies, and a whole bunch of scientific groups are looking at these questions. But, it took us 10 years to get the methodologies developed, 5 years for the restoration methodology under tidal wetlands, another 5 years for the conservation methodology. So I think, we're trying to streamline the process to move quickly, but it is going to take some time for the science and the questions about safeguards and the legal aspects to come together. But we're moving in that direction. And with that, Steve, maybe I'll pass it over to everybody else. Steve, if you're speaking, I don't hear you.
Sorry about that. I was on mute while you were talking. I was going to say we can open it up now to questions. It looks like Liz might still be there, but I know she's going to be disappearing in a second. Do we have any? I have a lot of questions, and if anybody else has questions, from the audience, let me know. And I'm sure I wouldn't mind getting Will and Steve going at it too, because I think there's or Liz, maybe Liz, before you go, if you do have any questions you want to throw in. I don't know if you're still there or not. She may be gone already. Here we go. Okay, here we go. There is a question from Oliver again, and he's saying, in your experience, what's the difference between a $20 per ton blue carbon project and a $40 one? Is it the cost of restoration, the SDG benefit, or both?
That's a good question. It's really coming down to deal making, and there's a whole range of the cost of projects. They can be relatively simple, or they can be very expensive. And so, if they're expensive, it's a challenge to even get going. And so that's not really. It's only slightly affecting the price at which the carbon is trading at, because some of the smaller projects, which are being more expensive, they've demanded a higher price because they needed to break even. These projects were done by non-profits, and to break even, they said, we can't sell for anything less than $30. And because we're relatively small, buyers came in and were willing to support the project. All of these projects have very high biological and social values. If they're well designed, and of course, they're, as well as the standard under Vera for the carbon part of it, there's the community conservation, community climate and biodiversity standard as well. And so these projects, demonstrate these other values. But when we look at the prices, it's really come down to deal making. The organizations, individuals are recognizing the value. They want to buy blue carbon credits. They're sexier. They recognize all these benefits that go with it. But at the project level, they may be selling at a certain price, but now it's getting into middlemen, and they are passing them on at a higher price. So I think what we'll see is that projects are going to get savvier, and they're going to just demand a higher price at the very beginning, and not let middlemen squeeze them out a bit, rather than having them sort of sell them on at a higher price, try and get the higher price themselves. And because it's very discouraging, because the Indus Delta project, for instance, took nearly 10 years. It has taken 10 years to get to this point. It takes a long time for these projects to come along, and it is. I think that from the seller's point of view, they're now becoming savvier that they can ask for more money, and buyers are apparently willing to pay it.
Yep, a lot of really interesting questions in there. And Oliver, feel free to throw in I do see Mark asked a question, but I wanted to just kind of pick this one up a bit, because the issue of price and what can be done on the ground is very interesting, because, and the role of the middlemen, because there's two things going on. One is the prices are going up just because demand is going up, but then the corollary of that is that as prices go up, more can be done on the ground, because there are, we can go for the higher hanging fruit, but for that to happen, more money has to actually go on the ground. There was an interesting piece that Jonah Bush did a few years ago on Red Plus. You guys might want to maybe just Google Jonah Bush, B-U-S-C-H, Red Plus, I forget the name of it, Red Plus price points or something. And he showed how quite clearly in the Red Plus area how as prices, like right now, the projects are being done by people who really want to make a change, and the money is what I call an enabling mechanism. It's helping them do what they already want to do but haven't been able to. The next level is going to people who are farmers and everything else, where it actually starts to really incentivize differences, and that changes quite a lot. And then another one I wanted to just ask real quick is something I'd heard on the Red Plus space that was beginning last year, is projects were getting into these risk-sharing agreements, similar to what the Leaf Coalition already mandates, which is if you sell it to a middleman at a certain price and they then sell it further, a certain percent has to go back to the people on the ground, so that there is automatically, that's a newer development that was kicking in last year when I was talking to a lot of project developers were beginning to do that already. So it was because they didn't want to enter into forward contracts because they expected prices would be going up. They wanted to enter into these types of things, which are kind of like an option. But by your reaction, it looks like that hasn't entered the blue carbon space yet, though.
No, I've not heard of that. That's a really interesting approach, and I think we might, when we're all going to be in Lisbon in a couple of weeks, gathering together all these buyers and sellers of blue carbon credits. So I think that's an interesting discussion point that we might have there.
Okay, let me go on to the next one. This is from Mark Gillespie. Mark asks, what are the chances the U.S. can reach zero net emissions by 2050? That's a very high-level question, but anybody want to tackle that one?
I'll take a shot at it. I think it's possible, but I think it's going to be an extremely heavy lift. I mean, even the estimates of what we're going to see in 2030, right, where we're essentially trying to get to 50% of 1990 levels, right, seems incredibly daunting at this point. It looks to me, if you eyeball it, that even best case scenario right now is maybe 35% by 2030, and a lot of the assumption of net zero in 2050 is necessarily premised on large scale carbon removal, right, to get to that net, and I'm extremely skeptical that we're going to get in that really multi gigaton sort of range, even by the time we get to 2050. Realistically, if you're going to get to net zero in 2050, you're probably going to need 8 to 10 gigs of CDR, and that's going to be a heavy lift. So I'll be surprised if we get to net zero in 2050.
That kind of brings up another question that I've always had, which is, did we this the way we've accelerated into removals when we weren't even, we haven't even ramped up the reductions component yet. Is this a mistake from your perspective? Have I lost you guys? You both froze. Oh, okay.
Oh.
There. Okay.
You want to start, Steve?
We may
I
have
think
lost Steve.
Steve is frozen.
Yeah,
Oh.
he was having connectivity problems
He'll come
before.
back. Okay, I don't want to hog the spotlight, but I'll start.
Okay.
So wait for Steve to come back. This is that question of so-called moral hazard, right? The idea that if companies can start claiming that they're going to get to net zero by 2050, and lots of companies, there's about 500 of them now, of the larger companies that have made that claim. The fear is that they'll premise that on really large-scale carbon removal that may never come to fruition, right? Either because there's going to be massive double counting, because there's a limited amount of carbon removal that one can purchase at this point, or because for all the technical reasons and risk reasons we've talked about, we never actually get to that scale, right? And we'll have carbon lock-in through another generation of fossil fuel production as a result, and then be really in disastrous straits when we get to 2040, 2050, right? That's the moral hazard argument. I think that there are ways to address moral hazard. The European Union is one approach. The EU is developing a carbon removal directive right now. And one of the things that it does is it limits the amount of carbon removal to about 250,000 tons, right, by 2030. So it's ensuring that it is a supplementary approach, and that most of the heavy lifting has to be in the context of carbon removal, right? So that may be one way to do it. Another way is to try to set standards that require maximum reductions in emissions before one can even go down the path of claiming carbon removal, right? But it's hard to know. One can be skeptical that that's what will happen. If you looked at what happened in Kyoto, for example, and how we designed standards for offsets, and whether we were going to limit the amount of emissions claims that could be done through offsets, we never really did that. I mean, it turned out the offsets market was a bust, but for different reasons, right? But we didn't clearly police it in a way that would avoid moral hazard. And there'll be a lot of pressure in this case to allow companies and countries to meet these net zero commitments or their NDCs in any way that they can, right? So ensuring the integrity of these markets is going to be an ongoing sort of challenge. And the press has a role to play in that, right? Really pushing to question whether companies are maximizing their emissions reductions, questioning the nature of the methodologies they're using for claiming carbon sequestration and so forth, is going to be critical in my mind, because there's going to be a lot of, economists call rent seeking and game playing in this market, as there has been in every other one.
Yep. Yeah, and I'm looking to see if Steve is pinging me, see if he's going to come back in. Hopefully he will get in here. It looks like a lot of our reporters are dropping off anyway. I'm wondering if a lot of people didn't realize it was an hour and a half. It looks like we had a big drop off right on the hour.
Yeah.
So we've only got 9 people left. But if any, there was lots of questions here. Hold on a second. Let me see. Let's see. So let me go ahead here. So yeah, Steve is having issues. Oliver is asking, I've seen a few blue carbon projects go through the Vera pipeline lately, but they seem pretty small in scale. Is Indus Delta an exception in the blue carbon sector? That's actually one for Steve, but he's off. Let me looks like we're getting a lot of good Steve questions here, and I'll see if I can. Let me ask him. Mark's got one further down that's more of a Will question here. He says, "Is there any realistic scenario where natural gas is no longer used by 2050?" That's a kind of a macro question. Is that for you, or is that outside your? You're the most macro guy on this call.
Yeah,
But that might.
I think it's possible. I think a lot of it is premised on how quickly we can scale things like hydrogen, for example, right?
Yeah.
And I think that's a difficult question at this point, right? And even a lot of hydrogen production, of course, currently is premised on the use of natural gas, right? So reaching the stage of true blue hydrogen is a challenge because of cost, because of energetics, scale. I think it's possible, but
Okay.
I suspect that natural gas will have a residual role in a lot of sectors, especially some of the hard debate sectors like steel, aluminum, and so forth.
Okay. And it looks like Steve is back, but probably conserving bandwidth. He's hiding his face from us. So, Steve, we do have some questions that look really targeted to you. One is from Oliver Lejeune again. He said, "I've seen a few blue carbon projects go through the Vera pipeline lately, but they seem pretty small in scale. Is Indus Delta an exception in the blue carbon sector?"
Yeah, the Pakistan is the exception so far. A lot of the projects have been small. The very early ones were under Plan Vivo, which were very small, but worked at the community level. Then there was the project with Apple and Conservation International.
Which one was that?
In Colombia.
Right,
And,
right, okay.
Yeah, but this one, in this first phase, actually, because there'll be another phase in Pakistan, is really enormous. But what I am seeing now is there are a lot of negotiations going on, and a lot of people looking for projects of the sort of 20 to 40,000 hectare scale around the world. And so I think what we will see actually within the next few years is an uptick in the number of sort of medium scale projects. But the project of the scale of the Pakistan Delta is probably going to be very rare,
Right.
because very few places have that level of space available with them. As I was mentioning when I got dropped, was that Indonesia wants to restore 1.8 million hectares, but how much can actually be done within those shrimp pond areas is yet to be determined. But there are some areas with space available, but not a lot. It's not like the terrestrial system,
Right. It's interesting too how many every project I visited was a Plan Vivo project. I don't think you've ever been to a Vera certified project. Is that just because Plan Vivo was their first, or because they focus on community forestry, or why is that? I should know the answer to this, but I don't.
Plan Vivo is a pretty simple standard, and it's really focused to help community development, and it has some climate benefit to it. But it's the Vera standard is really focused on developing bigger climate impacts,
Gotcha. Okay.
as well as having environmental and social benefit. And so the larger programs are much more rigorous, and Vera is the only one that thinks about sea level rise. And
Really?
And it's a critical aspect. If you need to develop permanence for 100 years, you've got to think about sea level rise as part of your project. And that does make it more difficult. You need to have people now in the team who can think about such things. And you need to think about space. So your project has to include not only where you're, let's say, planting mangroves, but where those mangroves are going to be in the future. They're going to move up slope. Do you have an up slope? Are there cities behind? So all of these things need to be thought together. And so that's why it takes a long time for these projects to come along, and that there was a lot of thinking went into the methodologies under Vera about some of these more complicated aspects.
Okay. Gotcha. Yeah, that's surprising that they're the only ones that factor in sea level rise, given the vulnerability that mangroves have. I mean, it's really inches make a difference, right? I mean, that's my understanding.
They can do. I don't want to get into the weeds,
Right,
but
yeah.
it depends where you are. If you're in a microtidal system, so coastal wetlands, marshes, mangroves, they exist only in the top half of the tide, so mean sea level rise and above to mean high water tide. And if you're in a microtidal system, let's say your tidal range is 50 centimeters, then your mangroves only exist within a 25 centimeter band, actually a bit less than that.
Wow.
And so a 10 centimeter rise in sea level is a very large proportion of that. However, if your tidal range is, let's say, 5 meters, 10 times that, your mangrove range is now 2.5 meters. And if your mangroves are at the top, they can take, 2 meters worth of sea level rise and not really notice it. So you have to look at the geography of where your wetlands are and how they're going to be impacted by sea level rise. Some are very sensitive, some are not sensitive at all.
Okay. Okay, let me get to
I will also mention, Steve, actually, since you got on that, you can also think about how one wetland is going to change to another. We did a study in the Tampa Bay where we looked at different development scenarios, sea level rise scenarios, and we projected that, over the next 100 years, the system under relatively friendly, under a system where you would allow migration back, the whole system, the mangroves, the seagrasses, the marshes, would sequester about 80 million tons of CO2 over the next century. If you didn't have so much space, the mangroves would be lost, but they would be replaced by seagrasses. Mm-hmm. And so the decline was still less than 10 million tons over 100 years. And so that was actually a surprisingly positive result, as long as you maintained a healthy ecosystem.
That's our last media briefing was on permanence and natural systems, and we didn't get into mangroves and seagrasses, but it's interesting to see how rigorous that can be if you manage it right. I do want to move on. We've got another question here because there are a few questions. Apologies to the people who sent them in. For some reason, a bunch of them popped up on my screen after like a few minutes after they were asked, and I hope you're still around. This is from Michael Keogh, all the way from London, and Michael is asking, will blue carbon credit supply be able to match demand over the coming years? The DBC has big volume, but will other projects be able to have similar estimated emission reductions? Biochar credits, so it's kind of similar now, to the question you just addressed. Biochar credits are being eaten up by big tech looking for high volumes. I feel like similar dynamics will take place with blue carbon.
Yes, right now, supply is way, way lower than demand, and we're trying to increase it a bit, but I think it's going to stay like that way for quite some time. And so we'll see about some of these, the seaweed farming coming on, and maybe some of the open ocean down-draw processes, which are going to be larger volumes. So we'll see about that. But there are a lot of technical questions to be answered before we can get into those. But I think we are just not addressing our climate challenge, and so the demand is going to outstrip the supply, I think, for a good while yet.
This might be one to get you guys going, because I see Will perked up at that mention, and this issue. Oh, we lost Steve. Crap. I was just going to say, I wanted you to ask him about, because this issue. I mean, everybody is talking about kelp farming, right, like it's the next big thing, and as Steve pointed out in his chart, he had seaweed farming bigger than kelp farming, but it's not ready for prime time. I know they are working on methodologies in Vera, and they're having the same problems. I mean, there's a reason these things take 5-10 years. And I'm wondering, maybe you could pick up on what Steve was starting to get at there, because it's a big issue.
Yeah. Well, one thing I think needs to be emphasized is
he's back. Okay. So yeah. So Steve, Will's going into the risks of kelp farming. So maybe he can go, and then you can pick up on that. So go ahead, Will. Sorry about that.
Right.
We lost him again.
Yeah. Well, but before risks, I talk about kind of limitations, right?
Yeah.
I mean, blue carbon is a relatively small contributor, right? In terms of the amount of sequestration we can get, especially when we're talking about needing 15 to 20 gigatons. Within that, if you look at kelp, for example, the National Academy of Science did a study on ocean-based CDR that was released in November, and one of the chapters was on kelp farming. And one of the statistics that should jump out is if you were to plant kelp farms in all of the coastal areas that it could possibly be done in a 100 centimeter band, okay, and that's never going to happen because so much of that would interfere with other things like tourism, fisheries, shipping, and so forth. But even if you could do it, put it in all the areas conceivably in coastal areas in a 100 centimeter band, it would only sequester 0.1 gigatons of carbon dioxide annually. Okay? In my opinion, a lot of this is overhyped. And there's questions about whether ultimately seaweed would attract and privilege certain sorts of diatoms, species that would alter the architecture of ocean ecosystems in a way that would be potentially disastrous for fisheries. And there's a new study that indicates that seaweed would also attract a lot of other species that ultimately would in themselves consume species that would result in respiration of carbon dioxide. And that study indicated that you could see a net increase in carbon dioxide emissions by massive use of seaweed farming, right? So I think we're at very early stages of assessing this, and I think there are risks that people don't think of. One of the things that I worry about when it comes to these so-called natural or nature-based solutions is that people glom onto them. They say, let's not look at direct air capture or mineral weathering because that's, big, nasty industrial processes, right? Natural is always good, right? But, it's not always true. If you plant huge amounts of trees and you wipe out prairie grasslands and savannas or draw huge amounts of water from water tables or use huge amounts of fertilizer, even though it's natural, it's not necessarily advantageous. And the same can be true with some of these blue carbon-based solutions. And kelp is kind of a quintessential example of that.
Yeah, that's actually the one of the big challenges in developing the standards is all of the negative consequences and the emissions that are released elsewhere. I think that's one of the reasons it took so long with biochar.
Yeah, and monitoring and being able to accurately measure the carbon flux in these systems and separating that out from the natural variability of these systems, the signal and noise ratio in these areas is a major challenge, right? Mm-hmm. Companies like Running Tide, for example, which is a startup company in Maine that wants to do seaweed farming, they have struggled with the ability to be able to accurately assess how much CO2 might be taken up in these systems. And if you can't do that, you're not going to be able to monetize, right? And if we create BS systems that allow them to monetize but don't accurately measure it, then it's dangerous, right? So I think we have a long way to go.
Yeah, I mean that's why. I hate to keep hyping it, but that's why they have these public consultations to get these methodologies done, because the stuff that comes up is I find them fascinating. 250 comments is just huge. I remember when they were doing the soil methodology at Vera, and I was not a part of it yet. Okay, here's Steve. I think we may have. Hey, Steve, we had talked about the. There might be one real quick, and because I do see another question from Lisa, I'll answer it real quick. Lisa, I think because Lisa is asking how is Vera progressing on CCU, that's DAX methodology development, and I'd have to check on the status of that. I know there's ongoing consultations. I don't know what stage of development it's in, but I'll look into that and I'll have to send you an email. Steve, we were just talking about the challenges of developing with kelp farming. Some of the and seaweed farming, and the issues of how do you quantify the emissions that could be generated as a result of the activities. I don't know if you could talk to that a bit, or is that,
Yeah, it is a challenge to quantify it. And because it's diffuse, unlike a forest or a mangrove, let's say, where the emissions reductions happen right on site. With these marine ecosystems, it now diffuses through the ecosystem. And so it does provide, there are global estimates, but there are people working on site-specific data collection, but yet really it does need improving in terms of that. If you look in deep sea sediments, you find seaweed carbon just about everywhere, and so it is being stored in the ecosystem. But we are getting into the more complicated parts about inorganic chemistry. How does that fit in? And sometimes inorganic chemistry can negate some organic carbon sequestration. Other places it adds to it. And so we're starting to get into some of the complexity. One of the points I heard Will make before Lost Connection is something I agree with. Really, when we think about what needs to get done, I do get concerned that a lot of these ecosystem approaches, blue carbon being one of them, is being talked about as if it can mitigate all of the emissions that are taking place, and that's not the case. Landscape still represents something like 24% of all total emissions that we have. We need to deal with those emissions themselves. But ultimately, we need to tackle the fossil fuel emissions which are happening. Once we get that, and as we're doing that, restoring the ecosystem helps draw down more quickly and bring us back to where we need to be. And so they are a small part of what needs to get done. I very much agree with that. I don't want us to get distracted from all the fossil fuel things that we need to do, which is a priori. But at the same time, we can also recover many of the ecosystem benefits and the social benefits that are not recovered when you just work on the fossil fuel part of it. And so, that's what makes it attractive to a lot of organizations. And is the recovery of ecosystems that we have been destroying with getting some climate benefit. But I really caution against what I do see as kind of blue washing, where people say, they kind of, you'll see polluters say, oh, we'll do some blue carbon, we'll sell coal to China, and we'll do some blue carbon restoration. And it's not like that at all. That we need to avoid those kind of blue washings.
Yeah. I mean, and that's there's a couple issues in there that I think people need to really keep in mind. I think that there's a consensus on that. Everybody, it's not either or. We need to do both. And the other issue is there just won't be. I can't conceive of how there could ever be enough of a supply on the offset side to ever. I mean, it's never. When I was in London at City Week a while back. That's where I met Michael Keogh, who's on this call. And I heard one of the executives, I forget which company he was with, but he said that they were planning to use offsets for 15% of their emissions.
Okay.
Yeah, and I'm just like, that's not possible. I mean, maybe it's possible for one or two companies, or it was possible in the past. That's just not, it's not doable. And so you have some people thinking, oh, we can just offset, which is just not possible. And then you've got people saying, you can't just offset. I think so. The second camp is saying, no, we've got to stop these guys from just offsetting. I think the real issue is it's just not possible, and hopefully as prices do rise, we'll get this. I think we'll find that place.
One of the things you might see coming out at Lisbon is a discussion from blue carbon project developers, or at least some of us, and definitely going to be going into the discussions into Egypt, is where we want to set criteria or guidance on what is a good financial partner for selling blue carbon credits to. And one of those criteria would be that they're actually making a very significant action towards reducing their own emissions first through other mechanisms. And then they're using blue carbon ecosystem offsets to get them a bit further while they're developing those technologies. And so we do want to be a bit holy about this, actually, on the blue carbon seller side, because there's only a few sellers right now, so we all we can chat and we have the same opinions. Of course, that might change as more sellers come in.
Yeah.
But we're very sensitive to this idea of being blue washed. And we are, and given that the demand far outstrips supply right now. It is, it is a seller's market in terms of who they want to sell to, and I think we just need to set the criteria for what that is. So we'll see how that develops.
Yeah, yeah. I hope that happens because I'm skeptical that companies like Vera and Puro, who are still profit-driven companies, right? And
well, we're nonprofit. Vera's nonprofit.
Well, that there's a monetary.
There is, yeah.
There's a monetary structure in place, and I'm afraid. I question whether they're going to be sufficiently stringent in terms of these standards, and so I'd like to have a backstop with those who are selling the credits, looking at these issues also to try to prevent blue washing.
Yeah, but for Vera doesn't. As I understand it, Vera doesn't get into the discussions between the buyer and the seller, so the seller can sell to whoever they want. Vera just provides a standard that tracks the quality of the project and then provides a registry. So it's really up to the buyer and seller to determine, so a polluter can come along and, offer a very high price and, they might sell to them. It's really the case, I think, of more broadly looking to see and putting pressure on companies to do a good job and the like. And it's not really, the Vera is not the police in this regard of the negotiations. Maybe there needs to be somebody else in there.
Yeah, well, there probably ultimately needs to be regulatory purview of this, right? At some point, if these markets become large enough, you're probably going to need, in my mind, government standards, and that isn't being discussed too much at this point. But I think ultimately it's going to be important to establish those standards. I don't really want to leave it purely to the private sector.
Well, we do have the VCMI, but that is a private sector initiative, Voluntary Carbon Markets Integrity Initiative, which kind of gets into the issues that Steve is talking about, which is how do you evaluate a claim? If your company, what's it? Do you hear me? Do you not hear me, Steve? Will, do you hear me?
Yeah.
Okay. Yeah, because the issue is how do you evaluate a claim so that a company they have to be showing they're doing something internally on top of this.
Steve, if you're speaking, we can't hear you.
Okay, Will hears me, I think.
Can't.
Yeah.
Yeah, Will hears me, right? You hear me, Will?
Yes, I do.
Okay. Yeah, Steve, I think you're in Silicon Valley, right? I think he's near San Francisco. He should.
Yeah, the irony. Well,
Yeah.
some of the worst internet connection around is UC Berkeley. So
Yeah. Oh, there is a real quick question from Lisa. There was a discussion in the VCM about a bottleneck in issuances of credits from registries. Can you comment on issuance delays and solutions being deployed to address influx? This is really for me. I can address that. The problem is, and this kind of goes back to there's the demand from Vera's side. We did an article. There was an article. Carbon Pulse did a good piece on this.
Can you hear Steve?
He hears me. Yeah.
Okay.
There was such an influx of demand, and what Vera had is a simultaneous influx of demand on the issuance side, with more projects coming in on the supply side, and a lot of people who don't really understand. They're new to the space, so they did a restructuring. But it just, it takes a while. It takes a long time. When a project is issued, they do a review, an accuracy and completeness review of all the documents, and you just can't rush that. There just aren't, they've hired as many people as they can, but it's a manpower issue. No, Steve, I think we're okay. I think we're at the end point here. Do either of you guys want to say anything, or I'll just say, Steve, let's see, final words, Steve. Let's see.
Well, I've lost connection, but I need to go to another meeting anyway.
Okay.
So happy to follow up with anybody. Steve's got my contact details. Feel free to get in touch.
Yeah. Okay. Thanks a lot. And Will, did you have any closing comments, or should we just?
No, I think that's it. Thanks everyone, and yes, Steve has my contacts also if you want to talk about any of the options. I guess the one other thing I would say is on the ocean side, um, uh, uh, be on the lookout for some of the other ocean-based approaches like ocean iron fertilization and ocean alkalinization enhancement and the electrochemical approaches that are being discussed, because ultimately. The oceans are a huge sink for carbon, right? And so when we look at carbon removal and its future, a lot of people are looking at the oceans as potentially, carrying a lot of this load, right? And so there are other things beyond blue carbon. They're in early stages. They all have risks, but they're interesting to cover also, I think, from the standpoint of what you're doing.
Okay. Okay, I think that's a good place to wrap it up. We only went a minute over. Thanks everybody for joining. Looks like we did drop down significantly. So I think we did lose about half our people at the hour, and then we lost a few after that. But I think we covered all we hit the high points. And thanks again, Will. I really, really appreciate you taking the time to share this with us.
You're very welcome.
And I'll be posting a video pretty soon, as soon as I can. It'll be on the Vera website since nothing was off the record. And if anybody does have questions and wants to reach either of these speakers, reach out to me. You've all got my contact info, and I'll set you up. Thank you very much.
Thank you, everyone.